might already know without actually knowing that you know it, which is, well, you'll see what I mean with this example. Let's say I've got just a flat surface over here, and I've got, let's say I've got a box, and here I've got a stick of dynamite that I've stuck to the box, and there I've got another box. Both of them have got the same mass. I cannot explain to you why I would do such an experiment other than the fact that one might have a bad liking for explosions, but bear with me for a while. So I light the fuse of the dynamite and we get an explosion. And if I look at this a bit later, let's assume this surface is frictionless. I see, well, this box is moving with a certain velocity. Let's say it's moving at 10 meters per second to the left, and this box is moving to the right. What will the velocity of that box be? How fast will it be moving in magnitude? 10 meters per second. If you want to specify its velocity, 10 meters to the right. Because you all have the sense that, well, here the total velocity is 0. I've got the same masses. Here I've got a velocity that, let's call this the x-axis. I've got a velocity that's equals to negative 10 meters per second along x. Here then, you all just said I've got a velocity, let's call this v1, v2, of 10 meters per second. It's along positive x, so I don't have the negative there. And if I add vector v1 to vector v2, I get, this is negative 10 meters per second plus 10 meters per second, everything along x, which is 0. So in this case, we've got two vectors associated with two completely different objects at two different points in space, but we all just realized it physically made sense to add them together, because before the explosion, the velocity of the system was 0. Afterwards, one part was moving at 10 meters per second in this direction, the other part was moving in the opposite direction, and we all had this sense that, hold on, the velocity, if the one is moving 10 meters per second this direction, the other one must be moving with the same velocity in that direction. And you all did the mental sum very quickly in your head that you must be able to subtract these two things to maintain this idea that velocity is 0. So this is a very nice example of where we will add or subtract vectors, even though they don't act on the same thing, they're not associated with the same point in space, but physically it makes sense to us. So we will play around with vectors even despite the fact that we associate them with different points in space.